Greetings from New York. Again, my name is Danny Huang. I am an assistant professor at NYU. So 3 years ago, my team and I started a project. We collect the network traffic from IoT devices from thousands of smart homes around the world. And today, I'm going to tell you about what we did, what we learned, and what challenges we faced. We study the smart home because they're getting increasingly complex and they're creating potential security and privacy problems. So many smart home networks include a large number of devices, both IoT and non-IoT. There could be devices that could be listening to you, like this one, Amazon Echo, or devices watching you, like this one, a camera, baby monitor. Devices that could track your video streaming habits, like smart TVs, devices that you can just remotely run on and off like light bulbs, but they could be running an old embedded Linux version that might be compromised. And on top of all these smart IoT devices, there could be non-IoT devices like personal phones, personal computers, and corporate phones and corporate computers, because hey, more and more people work from home these days. And all these devices are typically housed on the same trusted network. They can just talk to each other. No barriers. We don't know if they're passing, I don't know, sensitive information to each other. We don't know if malware moves from one to another. We just don't know. And we don't know because the security and privacy issues of smart home devices and networks can be rather opaque to both users and researchers. So let's start with users. Let's say I'm a typical user. I have a bunch of IoT devices. They're just black boxes. I don't know what they're talking to, who they're talking to, what they're doing. I don't know what's happening on my network. There are tools like Wireshark, TCP dump, but I, as an average user, would have no idea how Wireshark works, no idea how TCP dump works. That's like tools for highly technical individuals. So that's from a user's point of view. To one of the researchers. So as a researcher, security and privacy issues are opaque because of the lack of data. I may have to purchase different IoT devices and observe their behaviors in the lab. I may not have the money to buy thousands of them, and this limits the scale. If I want to study a large number of real-world devices, I could maybe ask company X in the audience to provide their data, for their private data. This approach probably works, but it makes it difficult for other researchers who don't have access to replicate my findings. So in short, users, no friendly tools, and researchers, it's hard to get large-scale open data sets. And with all these problems in mind, we developed an open source tool called IoT Inspector. TLDR, it's a monitoring tool for smart home users, and it crowdsources real-world IoT traffic data set for researchers. On one hand, it helps average users visualize what's going on in their smart home networks. So here's how it works. A user turns on their computer at home. The user downloads IoT Inspector to the computer. The user then runs IoT Inspector. IoT Inspector automatically captures traffic of IoT devices on the home network using a technique called ARP spoofing. In other words, the user doesn't even need any additional hardware. Just run IoT Inspector and he can capture, analyze, and visualize network traffic without additional hardware, without additional changes to the router. Basically, a few clicks, and users can see the visualization. So that's for users. And here's an example of IoT Inspector's visualization. So at the top of the screen is actually me watching the CBS News on Roku TV using the CBS News app, played at 10 times the speed. At the bottom is the real-time analytics, real-time analysis of IoT Inspector. Let me just continue playing, looping back. The horizontal axis here shows the time, and the vertical axis is the kilobits per second uploaded. So every colored bar is an advertising and tracking service. So remember, here I'm just passively watching the news, streaming the news, and the TV is communicating with 3 or 4 different advertisers, including Google and Adobe Marketing Cloud. If you look at the legend really carefully here down there. So that's one example of a user, that's me in this case, running IoT Inspector. Basically, we launched IoT Inspector in 2019, April 2019. Since then, Inspector has collected the network traffic from more than 63,000 devices. Note that this is traffic metadata, like the remote IP addresses, host names, and ports. No payload. And this data is aggregated over 5-second windows. More details in the paper. And these 63,000 plus devices belong to some 6,400 plus IoT Inspector users. We didn't pay them. They just downloaded the tool on their own. These users are anonymous, but a few individuals have come out and identified themselves publicly, including reporters from NPR, National Public Radio, and Washington Post. These folks used IoT Inspector to investigate privacy risks of smart TVs. And to our knowledge, this is the largest open data set of real-world IoT traffic. And a number of ongoing research projects are leveraging this large data set. That includes a study that we published in CCS a few years ago on smart TV privacy. We're building an IoT firewall based on allow lists. We're looking into how IoT devices encrypt their network traffic with TLS, and we're studying the public key infrastructure of IoT devices. We're studying like the software supply chain of vulnerable devices, and we're looking into privacy security issues and usability issues in a smart home space as usual. So this is just a tip of the iceberg, the current state of the IoT Inspector's research, and from both users' point of view and from a researcher's point of view. It's been what, 3 years since we launched IoT Inspector. We've been continuously capturing data, operating infrastructure, and attracting users. And in the rest of this talk, I'd like to talk about some of the lessons learned and the challenges that we faced. Challenge number 1, identifying devices and labeling devices. This is in response to the question from users, common question from this user. Like, what is this device? So here's what I mean. When a user runs IoT Inspector for the first time, Inspector typically shows a list of devices like here on the left. The user can choose one or multiple devices to inspect and have the traffic captured and view the analysis. The problem is, which is which? Many users have a dozen or so, like myself, have 30 devices in their house. These devices are typically identified by IP addresses, MAC addresses. And IoT Inspector has some ways to guess which device is which, but there's definitely room for improvement. In many cases, we just don't know what this device is. Expressive device, like what is it? Many IoT devices use expressive as the chip maker. So we currently use these features to guess the device so far. That includes the OUI, basically the first 3 bytes of the MAC address, but this may or may not be the actual manufacturer. Like Google may use a Google OUI, but many smaller smart plugs may use expressive as a generic chip maker for the wireless chip. So sometimes not very helpful. And we look at sometimes DHCP host name, may be helpful when you have some devices that announce themselves via DHCP. Same with HTTP user agent. Only in cases where the traffic is unencrypted, but some cases you will see things like what curl, like what is that? Sometimes MDNS and SSDP UPnP announcements where devices announce who they are, like a Chromecast. And sometimes the host names being contacted may be helpful. For instance, a Roku TV would probably most likely contact Roku.com. So in addition to inferring all these using all these features, IoT Inspector also asks users to label their devices with the names and manufacturer of devices. This is a crowdsourcing effort. So effectively, we've crowdsourced device identities from users, but the user labels can be messy at times. There are 3 problems, basically, with user labels: missing labels, inconsistent labels, and at the bottom, wrong labels. Missing labels. Slightly less than half of the users labeled at least one of their devices, telling us the names and manufacturers of devices. And of all the devices, roughly 25% have user labels. So that's missing labels. And there are inconsistent labels. So currently, users label their devices through what you see right here on the screen, a user interface, where users are shown a drop-down box where they select names and manufacturers of devices in a drop-down box. But we know that we can't possibly list all kinds of devices in a drop-down box, so we let users type whatever they want. That's a problem. Sometimes users type Amazon Echo. Sometimes users type Amazon Alexa. Sometimes, in this case, users type Amazon AI Assistant. Like, which one of these? I mean, they're the same thing, but these appear as 3 different labels in our data set. So that's a problem, inconsistent labels. And then there are the wrong labels. We have seen cases of what looks like a smart fan communicating with some large number of domains, including some Android-specific domains. And we check this particular smart fan model, it does not run Android. So potentially, the device is labeled incorrectly. So in short, we can gather a large data set from real-world users, but we need to improve the label quality and quantity. So that's a problem, challenge number 1. Challenge 2, how to communicate risks to users without sometimes spooking them. Typically, we answer this question from user, like, what is my device doing? So earlier, we showed you this particular video of me watching the news on the Roku TV while running IoT Inspector. If you remember, every colored bar here shows an advertising and tracking service. And how do we know it's an advertiser? Well, we look at the DNS traffic and match against known blacklists for advertisers. But what if certain DNS packets are missing or just cached? When that happens, Inspector doesn't know what company a device is talking to. So here's an example. If you squint hard at the bottom, here's an example of a company that we don't know what's going on. Like, this smart TV is talking to LifeX.io, ? Like, we don't know what it is because we don't see. We probably see an IP address. We don't know. We don't have the corresponding DNS packet. We don't know. We haven't seen the SNI in the client hello. We don't know what who the TV is talking to. Just one example. And even if Inspector knows the remote hostname, the user may not know what the remote hostname means in terms of the device's activity. So, real example: Belkin Wemo Smart Plug. Many of them talk to this domain hostname called api.xbcs.net. What is xbcs.net? It doesn't bear the name of Belkin or Wemo, the company. And if you visit xbcs.net in browser, there's no web server. Basically, it's hard to tell what XBCS is doing, what it is, and what the device is doing. And the truth, on the other hand, could be spooky sometimes. So, real story. We had a user email us. They said, "Oh my God, my device is communicating with the military domain as shown on the screen. Is the military spying on me?" So it turns out that this domain is an NTP time server. There are thousands upon thousands of time servers in the world. It just so happens that this person's smart device is using this particular time server operated by the Navy. So in general, it's tricky how to communicate device activities to users. Information could be missing. If it's not missing, we need to be careful how to communicate it and not spook the users, especially if they don't have a strong technical background, like in this particular case. Third challenge, incentivizing users. Basically, how do we convince more users to use and keep using IoT Inspector? This, after all, is a crowdsourced study. We need more users and more user engagements. And since we don't pay them, we need to build a better product for them. So let me show you some stats first. Our users have collectively scanned for more than 200,000 devices, as represented by this horizontal bar. Users inspected about a third of these devices, meaning that they had IoT Inspector capture and analyze the network traffic for about a third of these devices. These devices correspond to about 6,400 users, but the median duration of running Inspector is about 40 minutes. And remember, we want not just the traffic, we also want labeled devices. In particular, which device generated which traffic flow. Only about a quarter of the devices were labeled, and these correspond to about 2,900 users who labeled the names and manufacturers of devices. So there's definitely room for improvement. For instance, longer duration beyond 40 minutes. Can we encourage users to run Inspector for days, for weeks? Can we get more users to inspect more devices and label more devices? More incentives. And since we're not paying users, we can potentially attract more users and keep them engaged longer by building a better product, one with better user interface and better user experience, for example, by offering more usable information about what their devices are doing behind the scenes. And we're right now partnering with Consumer Reports Digital Labs to create a much better user experience, one that is tailored toward average consumers who are concerned about security and privacy and data usage in the smart homes. We can also increase the duration of use by deploying Inspector on Raspberry Pis. A similar project is Pi-ho, which runs on Raspberry Pis and blocks advertising traffic using a known block list. It shows a nice, nice looking dashboard. So this is where we're trying to learn some lessons too. We ran a number of focus groups of users, and one common theme is that users want not just transparency, information, but they also want actions. And one aspect we can learn from the Pi-ho project is blocking. Can we let users block devices and certain connections? So let's say a user has an indoor camera. Can the inspector block the camera when the user is at home, but unblock the camera when the user is out? So these are some of the work in progress for the upcoming Inspector version. And also, some users take Inspector outside to the homes. Can they do that? So a few days ago, I saw this tweet. Someone checked into an Airbnb apartment and found this, hidden cameras disguised as sprinklers. Can users bring IoT Inspector to Airbnbs to discover hidden devices, or some of the ethical issues? So these are some of the things that are keeping us busy right now. So lots of questions, lots of open challenges. The past 3 years have been an eye-opener for us. We gather a large traffic data set from a large number of users around the world. We faced a lot of challenges and we learned a lot. I'm happy to take any feedback from the audience and make IoT Inspector even better for users and researchers. My name is Danny Huang. We can chat offline. We can find my contact information down here and visit my website. Yeah, Q&A time.